Hello there, and welcome to Chemistry Chapter 1, Lecture 2. In this lecture, we're going to cover On Your Own Problems 1.6 through 1.12. And in the book, we're on page 12, and we'll go through about page 21. So you'll need your notes, a highlighter, calculator, and, of course, your textbook. And in the textbook, the first problem that we're going to work is on page 13. Okay. So let's go ahead and look at page 13. Now what we're doing in the next three problems are the multi-step unit conversion. And with multi-step, that means we have to convert to a base unit first. We talked about the base unit in yesterday's lecture. And if you want to look back, you can see the base units in this very first table: gram for mass, meter for distance, and liter for volume. Okay. So let's take a look at On Your Own 1.6 on page 12. So that one says a balloon is blown up so that its volume is 1,500 milliliters. What's its volume in kiloliters? Okay, so we're starting with a really small unit in milliliters. We want to go to kiloliters, but we're going to have to convert to the base unit first for volume, so that would be liters. We don't have an easy way to go straight from milliliters to kiloliters. So we're going to do it this way: go through the base unit, because the milliliters is on the left side, or the smaller side of the base unit, and kiloliters is on the right side, or the larger side of the base unit. Okay, so let's start with what we've been given, which is 1,500 milliliters. We're going to put that over 1. Now we're going to convert to the base unit first. Do it by units. Liter on top, milliliter on bottom. Now which one's bigger, a liter or a milliliter? Well, hopefully you remember from yesterday that the liter is bigger and that there are 1,000 milliliters in a liter. Now we can go to the final destination, the kiloliter. And we're going to cancel out the liter. If you forget which one you want to cancel out, just go over 1 and up 1. Over to the left and then up 1, and it's liters. So it's the one that was in the previous parenthesis but on top. What's bigger, a kiloliter or a liter? Well, a kiloliter, just like a kilometer or a kilogram, that's the big one. So the one goes by the big one, and there's 1,000 liters in a kiloliter. Okay, so the thousands are both on bottom, so we divide here. Okay, so the way I would do it, start out with 1,500, divide that by 1,000, and it's usually safest to then just go ahead and hit enter. And then again, divide that by 1,000. Hit enter every parenthesis, and you'll get 0.0015 kiloliters. So we're in the unit that we ended up with on top. So because of the factor label method, we have milliliters canceling and liters canceling, and we're just left with kiloliters. All right, let's try 1.7. So why don't you pause the video, and based on this example I gave you, try it, and then come back and watch it. Okay, let's see how you did. So on this one, just reading through it, says if the length of a race car track is 2 kilometers, how many centimeters is that? So we're going from kilometers to centimeters. So kilometers is the big one. Centimeters is across the base unit. Well, the base unit for distance is meters, and then we can go to the little one, centimeters, like that, okay? So we must go across the base unit first, or through the base unit. All right, it says we have 2 kilometers. That's what we start with. Let's put that over 1. We want to go to meters, so put the unit first. And we want to eliminate or cancel out kilometers. That one right there. Kilometer is bigger, so put a 1, and there's 1,000 meters in a kilometer. Has any one of you ever run a 5K? That's 5 kilometers, which would be 5,000 meters. Finally, we want to go to centimeters, and we want to eliminate meters. So we're going to put that on bottom. A meter's bigger than a centimeter. How many centimeters are in a meter? Well, don't say 1,000. That's millimeters. Centimeter, century, right? Centi means 100. Okay, so there's 100 centimeters in a meter. So this time, all of our multiplying is on top. Now, it can be both. You can have one on top and one on bottom. So then you'd multiply and divide. But in this case, right, we start with 2. We multiply that by 1,000. Going to go ahead and hit enter, and then we multiply that number by 100. Okay, and we've got 200,000 centimeters. All right, so hopefully you got it right. If not, then I hope you understand it now. All right, on your own 1.8. Page 12, it says, how many megagrams, mega, big M, megagrams, are there in 10 million milligrams? All right, so if we go back to yesterday's notes, so megagrams is not something you have to memorize for the test, but it's good to have a problem. Mega means a million, okay? So it's a really big unit. All right, so we're going to start with milligrams. And then we need to go through the base unit, which is grams for mass. And then we can use that base unit and go all the way to the big M, megagrams. So our base unit is grams. Okay, so we've got 10 million milligrams. And put that over 1. We're going to grams, and we're eliminating milligrams. All right, so we put that on bottom. That way it cancels, and I forgot to cancel on the last one. You don't have to do that, but it helps. Okay, which one's bigger, gram or milligram? All right, it's the gram. How many milligrams are in a gram? There's 1,000 milligrams in a gram. Now finally, we want to go to megagrams, big M. We want to eliminate the one on top in the previous parenthesis, that's grams. Which is bigger? Well, mega is bigger, of course, so put a 1 by megagrams. How many grams are in a megagram? It's 1,000,000. Okay, so in your calculator, you're going to start with 10 million. Divide that by 1,000. Just for safety, I then hit enter. And then divide that number by 1,000,000. All right, so that's 1,000,000. Hit enter. And you'll get 0.01. And don't mess up the unit. You're in megagrams because grams canceled, milligrams canceled. All right. So great. So that's how to do a multi-step unit conversion. So we are at the bottom of page 2 on our notes, adding and subtracting units. In order to do that, the units have to be identical. All right, if you want to add and subtract units. It's not true for multiplication and division, but for adding and subtracting. So the example I give in the notes, you can add 3 meters plus 4 meters. That's going to be 7 meters, right? But let's say if you wanted to try to add 4 meters plus 7 grams, that doesn't make any sense. Okay, different units, you can't add and subtract. All right, so if you'll turn to the top of page 3, while I erase here, we will go through the density equation. So the density equation is given now because that's an example of multiplying or dividing units. Okay, so you do need to memorize this density formula. Density is mass over volume, and it's any mass unit divided by a volume unit, but in our case we're going to be usually using grams per milliliter. And density is symbolized by the Greek letter rho. That's R-H-O. Okay, and it looks kind of like a P. It's kind of a curvy P, and that's equal to mass over volume. So the density units, grams per milliliter. So the mass in grams, the volume in milliliters. All right, so another thing, the next thing on the notes that you need to go ahead and highlight is 1 cubic centimeter. A cubic centimeter, so that's a cc, is another way to say that is like this, centimeter cubed. That's another way to say cubic centimeter, and that's just a milliliter. So if the problem asks you for a cubic centimeter, it's just asking for milliliters. Okay, so you may want to highlight that. All right, and I also say in the notes, read example 1.4 on page 16. So that might help you out. That's the book has these examples in blue. I don't work those in class, but they can be very helpful to read over these. So the examples in the textbook are really, really helpful to read. Okay, so using that information, let's work the next 3 on your own problems. So we're going to do 1.9 on, let's see, this is the bottom of page 16. All right, so let me get that into view. So it says, a braggart tells you that he walks 100,000 centimeters each day. He expects you to be impressed with such a big number. But should you be impressed? And then the author says, convert the distance measurement to miles in order to determine whether or not to be impressed. Okay. So we're going to be converting from metric to English because miles are an English unit. All right. So we're going to be going from centimeters. All right. And then from centimeters, we could go to inches because in our notes we have a centimeter to inch conversion. Then we can go to feet because you know that there are 12 inches in a foot. And at that point we could go to miles because there's 5,280 feet in a mile. All right, so this is a 4-stepper. We're going to have 4 sets of parentheses. So 100,000 centimeters. We want to convert that to inches, and we want to cancel out centimeters, so we put that on bottom. Inches are bigger, and there's, if you look at page, I believe it, let's see. Of course, you have to memorize this, page 2 of your notes. 1 inch is equal to 2.54 centimeters. All right. Now we're here in the step. We're in inches. Then we want to go to feet. We want to cancel out inches, so we put that on bottom. There's 12. There's foot's bigger, right? So put 1 by the feet, and there's 12 inches in a foot. And then finally, we can go from feet to miles. So we put miles on top. We want to cancel out feet, so we put that on bottom. A mile's bigger than a foot. And in the text, it tells you, you may have learned in other science classes that there's 5,280 feet in a mile. Now, you won't have to have that memorized for the test, but you do have to have this 2.54 centimeters is equal to 1 inch in the test. Okay, so let's go through this. There's going to be, all of these numbers are on bottom, so there's going to be a lot of dividing here. All right, so we start with 100,000 centimeters. Going to divide that by 2.54. Hit enter. The next thing we're going to do is divide it by 12. I'm going to hit enter. and then divide that number by 5,280. And we have 0.62 miles. So, should you be impressed? Well, that depends. Probably for the normal, able-bodied young human, no. However, a person that doesn't have any legs, that's pretty good. So it depends on the situation. All right, so that's actually 100,000 centimeters, just happens to be a kilometer, which is 0.62 miles. All right, let's take a look at 1.10. We're still on page 16. That asks us, how many cubic centimeters are there in 0.0045 kiloliters? Well, what did I say a minute ago? What's a cube? What's another way of naming a cubic centimeter that might be useful in this case? All right, it is a cubic centimeter is just a milliliter. So this is a multi-step conversion. We're going to go from kiloliters to the base unit liters and then to milliliters, which is the same thing as a cubic centimeter. Same thing. Okay, so we are at 0.0045 kiloliters. I'm going to put that over 1. Let's go to liters. So we had to go across the base unit because that makes it a multi-step conversion. We want to cancel out kiloliters, so we put that on bottom. A kiloliter is the bigger one, and there's 1,000 liters in a kiloliter. And then we're going to go to milliliters, which we know is just a cubic centimeter. And we want to cancel out liters, because that's where we're at now. Liter is bigger, so put the 1 by it, and there's 1,000 milliliters in a liter. So this time, we're going to take 0.0045 kiloliters, get it over here, times 1,000. I like to hit enter in between. You wouldn't have to. Then times another 1,000. So that's 4,500 milliliters. So your unit is the one that ends up on top in the last set of parentheses. Everything else cancels. All right, on your own 1.11. And then we'll talk about a different topic. So 1.11, bringing the book into view here, says the area of a room is 16 square meters. What is the area of the room in millimeters squared? Okay, this one is a little bit on the tricky side, but I'll tell you how to do it. Okay, we're starting with meters. So this isn't multi-step because meter is the base unit. So 16 meters squared. We want to know how many square millimeters. Okay, so the way this works is that we want to go to millimeters on top, meters on bottom. But that's not quite enough. I'll show you in a minute. A meter is bigger, and we know there's 1,000 millimeters in a meter. However, we need to cancel out meters squared. But the squaring that you do has to be on the outside of the parentheses. That would get you both millimeters squared and meters squared, and then we would have cancellation here. So in your calculator, the way you do it, I'll put it here, 16 times 1,000, but you have to square that 1,000, all right? Now, you don't have to square the 1 underneath. 1 squared is 1. So square the 1,000. So find the x squared button, and you can see 16 times 1,000 all squared. Hit enter, and you end up with 16 million square millimeters. So that's a unit of area. When it's a unit squared, that's a unit of area. When it's cubed, that's a unit of volume. All right. So we're going to go to a little bit of a different topic before we finish lecture number 2. Sorry about that. You hear my music stand rattling. I'll get that fixed before the next video. Maybe you don't hear it. I don't know. Okay, in our notes, we're going to talk about accuracy versus precision. So accuracy is how close a measure is to the true value. So it's the quality of the instrument. All right, the better quality the instrument, the more accurate it is, the closer it'll give you a reading to the true value. Precision has nothing to do with accuracy. It indicates the type of scale on an instrument. So I'll give you a little bit different example than what's here in your notes. Let's say we have a scale, all right, just a bathroom scale. And let's say that my true weight is 165.2 pounds. Okay, that's my true weight. Scale 1 reads, if I get up on it, then let's say it reads 164.9 pounds. So it goes to the 10th place. And it's pretty close to my true weight, right? Only 0.3 pounds off. And let's say that scale number 2 reads let's say it's a fancier, more expensive scale, and let's say it reads 167.35 pounds. So just making that up. So this scale goes out to the hundredths place. So it is the more precise of the two, because it goes out to the hundredths place. But this scale was closer to the true value, closer to my true weight. So it only goes to the hundredths place, but it's more accurate. All right, and I could have come up with a situation where the precise instrument was also the most accurate. But just because it goes out to more decimal places doesn't mean necessarily that it's more accurate. It could be, but it might not. So that's the difference between precision and accuracy. And in the classroom, when I taught in the classroom, I would get out a graduated cylinder, which has, which you might ask your teacher to do. A graduated cylinder has just a lot of different readings. In fact, you can read it down to the millimeter. And I would also then get out a beaker. And a beaker typically only has, for a 250 milliliter beaker, it may only have a line every 50 milliliters, okay? And here you can read it down to the 1 milliliter, and on a beaker, you've got to guess in between there, kind of. So this would be the most precise. All right, am I spelling precise right? I think so. And of the two, and we don't know which one would be more accurate. It depends on where it's manufactured, and how good a job they do painting the lines on. Okay, so let's talk about significant figures. So this has to do with the precision of equipment and what you can report equipment to. So on your notes, you'll need to memorize this. A digit is significant if, all right, so this is a method of determining the precision of a measurement, significant figures. If it's non-zero, so rule 1, so let's see, sometimes it's called significant digits, significant figures. All right, rule 1, non-zero. So if it's non-zero, it's significant. Rule 2, it's a zero between two significant digits. or figures. And 3, it's a 0 at the end of the number so it's got to be at the end and to the right of the decimal. So it's got to meet both of those to be a significant figure. Now, you've got to learn how to figure out the significant figures, and then that teaches you how you can round your answer. So the rounding we'll do in Lecture 3. But right now, I just want to teach you how to determine significant digits. So let's look at on your own 1.12. And this is several pages over, pages worth reading. And I'm actually going to do more of these than what's in the book. So we're on page 21. And example A says, how many significant figures are in 3.0220? Okay, if it's not a 0, it is significant. So let's see if I can get a different color to work here. See if this red will work. Okay, so the 3's not a 0, the 2's not a 0, the 2's not a 0. That means those two are significant. But what about the 2 zeros? Those are the hard ones. Well, this 0 is between two significant digits, so it does meet rule number 2, so that works. And this 0 is at the end of the number and to the right of the decimal. So for example A, all 5 of these digits are significant. So the answer would be 5. All right, B, we have 0.0060. And the leading 0, if there's a leading 0, it's never significant, okay, like that. We're just right out in front of the decimal. All right, so let's figure this one out. So the unit doesn't matter here, okay, it's meters. Okay, I'm going to use the red one. All right, so we know the 6 is significant. It's not 0. So what about the other zeros? Okay, well, we've got a 0 at the end of the number and to the right of the decimal, so that one is. But how about all these leading zeros? They're not between two significant digits, and they're not to the right of the decimal and at the end of the number. So none of these leading zeros are significant. So the answer here would just be 2. All right, example C is 1.00450. So let's go ahead and get the non-zeros. We've got a 1, a 4, and a 5, so we're up to 3. We have a 0 at the end of the number to the right of the decimal, that is. Now, how about these 2 zeros? Well, if there's a bank of zeros, multiple zeros in a row, and they are between, all that bank of zeros between two significant digits, then they are all significant. Okay? There could be 50 of these zeros in a row, but if they're between two significant digits, all of them would be significant. So in this case, we have our answer is 6. All 6 are significant. All right, let's try D. That's 61.054. Okay, I think you'll find this one pretty easy. We know that the 6 is, the 1 is, the 5 is, the 4 is. It's just about that 0 there. Is that 0 significant? Well, it's between two significant digits. It meets rule number 2. So this one is 5. Okay, so here are a few extra ones to make sure that you have this concept down. E isn't in the book, but I'm going to tell you, how about it's just 5 million? No decimal. 5 million. Well, we know the 5 is, that's non-zero. But what about all these other zeros? They're not to the right of a decimal. There is no decimal. They're not in between two significant digits. None of these are significant. So the answer is just 1. None of these zeros qualify. All right, example F is, all right, this one will be fancy. 3 zeros, a 3, 2 zeros, a 4, and 2 zeros. Okay, let's do the easy ones first, the non-zeros. Doink, doink. All right, how about all these zeros? Well, do we have a 0 to the right of the decimal at the end of the number? Yes. What about the 0 in between these two? Well, they're both significant, so that one's significant. What about this 0 in between the 3 and the 4? It's between two significant digits, so that's significant. What about all these leading zeros? These zeros are not at the end of the number. None of these zeros are between other significant digits. So the answer is 5. All right, how about 770.00? Now, why don't you pause the video and try this on your own? See if you got it down. Okay, welcome back. We got a 7 and a 7. So it's all about the 3 zeros. We've got a 0 to the right of the decimal at the end of the number. How about these 2 zeros in between, the last 0 and the 7? Yeah, they meet rule number 2, between two significant digits. So in this one, all 5 are significant. And then our final example of this lecture is H. So let's see if I can fit it in right here. We've got 0.00003. All right, why don't you pause the video, try that real quick. Okay, so welcome back. We have a 3. What about all those leading zeros? Are any of those significant? Well, they don't meet rule number 2, and they don't meet rule number 3 because they're not at the end of the number. They're to the right of the decimal, but not at the end. So this example H only has 1 significant digit. Okay, so the homework from this lecture is the review questions on page 35. You can do 6 and 7, and then the practice problems on page 36. You can do numbers 5 and 6. All right, so hope this lecture helped you. You can also, if you're having any trouble with significant digits, you can read example 1.5. It'll be really helpful for you. Always read these examples in blue if you're having trouble. And I will talk to you for lecture number 3.